All right, here's a lab that we should be doing together in class, but obviously that's not going to happen. So I am going to uh, do this for you, but just pretend like you're doing it. You are going to write an individual lab report on this. Uh, it's just an activity, so there's no graphs or anything. You're just going to use Snell's law, which we um, have talked about. You're going to use Snell's law to determine the index of refraction for 4 different substances, knowing that the index of refraction for air is 1. That is the given, that the index of refraction for air is 1. So I'm going to start off with olive oil. So I'm going to shine light. Well, the first thing I did, I grabbed a trough. We have these empty troughs. And I placed it on here. I've already done this, of course. And this is part of your procedure when you write up a lab report. I placed this down on the piece of paper, and I drew around the trough. I got a protractor, so I traced around the trough. Then I took it off. So I traced around the trough. I grabbed the protractor, and I measured out to 90 degrees and drew in the normal. And then I measured out 45 degrees and drew in what the incident ray that I'm going to shine my laser light along. Okay, I've done that for the olive oil and for the other 3 substances. There's something special about the olive oil. I was going to skip it, but then I thought I can't skip it. This olive oil, you are missing the smell, which is such a shame. But, it is what it is. This is the 22nd time I've done this, and I have been here for that long, and this olive oil is older than that. I've got this Costco-sized thing of olive oil that somebody bought before I got here, and it is my goal to get through my entire teaching career using the same olive oil. It is so disgusting. You are missing the smell, which is just beautifully awful. I had a student once said, Mr. Wyman, why don't I'll buy you some new olive oil. I'm thinking, what? You don't get it. The goal is to get through my teaching career with the same olive oil. What's cool about this? If you had a sister I have some students that took, whose sisters took my class like 20 years ago. Yes, I do. They use the same olive oil. It's like a tradition. It should be part of the alma mater. Xavier will remember the olive oil. Yeah. So anyhow, life is good. So here's the olive oil. I'm going to shine the light, the incident ray along 45 degrees, and I'm going to mark where it comes out over here. Let me grab a pencil. Okay, I'm going to mark where it comes out over here, right around there. Make that mark. I'm going to remove the olive oil. Got to be careful. This stuff's like liquid gold. Find my protractor. Here she be. And connect the dots. This is the path that the light follows. Now, I'm not being extremely precise, which is just the way it is with one person doing this. And I might want to double check that, but whatever. So that looks like it is at, you know what, do it this way. Hold on, Bruce. What is it, about 40 degrees? No, 30 degrees. Yeah, that looks like 30 degrees, doesn't it? We're calling it 30. So you want to write that down in your data table. The incident ray is 45 degrees. Just double check that. (45 degrees), and then the refracted ray is 30 degrees to the normal. Again, so theta I is 45, theta R for the olive oil is 30. Write that down in your data. Okay, now we're on to the water. The water has not been around for, that I'm aware of, at least in my room, for 30 years, or 22 years, 30 years. It came right out of the tap just moments ago. So I've traced around the trough. I used a protractor to draw on the normal where I'm going to shine the light ray at that point, right at the very middle. Then I used a protractor to measure out the 45 degrees. Let's place this right here. We're going to do the same thing. I use 45 degrees as my angle of incidence. My index for the incident medium, which is air, is 1. And let's see what happens. We'll figure out the angle of refraction. I don't know how well I've done that. Okay. So it's coming out right here. Boop. Good enough for government work. So again, it has deviated because if it hadn't, it would have gone out over here somewhere, but it didn't. It came out over here. So let's measure the angle of refraction in the water. Let me see. It's kind of hard with the lights down, but you can see the laser better with the lights down, but you can't see the reading as well. That's about 30 degrees too, which I'm not too surprised. They shouldn't be exactly the same, but I haven't been very precise. I'm going to call that 31 degrees. All right, so that's about 31 degrees. So angle of incidence for water is 45 degrees. The angle of refraction is 31 degrees. Okay. Let's do the glass block. So here's my glass block. And I just placed the glass block on the paper and I drew that line. Okay. Then I used a protractor. I did this at the edge, and I'll show you why in a sec. And I drew in the normal and drew in the 45 degrees using a protractor and the straight edge. Let's place this here. It's important to line it up properly, and I don't know how careful I've been with the line because it obviously matters. But whatever. So this one, I'm going to, you can see the reflected ray is kind of cool. The light's coming out over here. I didn't want to shine it over here because it gets weird. It bumps into the corner. That's why I went over here to this side. So that's about right there. Whatever. Now these are going to all be fairly similar. If I'd done this correctly, and again, I'm not being all that careful here, then I would expect it to refract, excuse me, more in the glass because the glass is more dense. But all right, so this is gosh, let me see, what is that? That's about 28 degrees. All right, and I don't know how much I trust my results, but I do expect that the glass is more dense, so I did expect it to bend tighter in the glass. Let's do the last one. So again, that for your data table, 45 degrees incident ray. I know that's blurry, I'm sorry. And 28 degrees refracted. And the glass block, I hope that clears up on the reading. So that's the plastic block, excuse me. Come on. Dang. I'm going to turn on the light. I'll be right back. Don't leave. Okay, that's focused better. So the plastic block, I did the same thing. I put this down, I drew the straight line, took it off, drew the normal. You're using a protractor. And same thing with the incident ray. And I'm going to shine the light. Let there be light. So it's coming out right around here. Right around there-ish. Good enough, considering the circumstances. And we'll see what we get. There is the refracted ray. So incident ray of 45 degrees. Refracted ray of about 20. It's a little, about 28 also. Yeah, maybe a little bit more. But I'm going to call it 28 degrees also. That doesn't surprise me that that's pretty close. All right. So again, if I were more accurate, then these things probably wouldn't be exactly the same. I'd expect the plastic to be a little less than the glass, but to not as bend quite as tightly. But I bet we're going to be pretty darn close considering. This is actually how we figure out indices of refraction. I mean, it's one of the ways to figure it out, but you'd have more precise measurements if you really wanted to know these things by just measuring angles. That allows us to come up with the N value for various materials. So again, you've got your four materials with their respective angles of refraction, and you can calculate the index of refraction. When you're going through the calculations, come up with the index for all of these things. You really only have to show me one sample calculation, so you could pick one of the items, plastic or water or whatever, and go through the calculation for it, and then just put all the other ones in a table. It's a very simple report. The conclusion should just say what did you get for the index of refraction for each one of these things, and does it make sense? Remember, it only makes sense if the index of refraction is greater than 1. There's no such thing as an index less than 1. And it should be less than 2, because greater than 2 is like diamond, and no, I don't have any diamond blocks. So anyhow, that's that. Bye.